Thank you very much, everyone, for coming. We are going to be talking a little bit about like simplifying cloud-native application testing across environments. It's a complicated subject, like distributed applications. So let's get it done.
Yeah, sure.
My name is Mauricio Salatino. I am a Dapr like ecosystem engineer at a company called Diagrid. This is a small startup in the US. And I'm working at a project, the CNCF project that's called Dapr. It's all about Kubernetes and stuff like that. So how many people here is using Kubernetes today? Okay, yeah, that's good. Compared with like previous years, that's pretty good. So that's great. And I'm here with my friend Laurent.
Yeah, morning. So my name is Laurent, and I'm working at Postman. Who knows about Postman? So yeah. We are not talking about Postman at all. Yeah. Postman is the sponsor of the Microcks CNCF project, and I'm purely dedicated to Microcks these two last year. So that's what we are going to talk about.
That's good. And I do still consider a developer myself, but I've been working with Kubernetes for some time. So in 2023, at the end of 2023, I published this book called Platform Engineering on Kubernetes. And we are currently writing this book that is currently on early access program titled Developer Experience on Kubernetes with my friend here, Thomas Vitale, mostly because we believe that it's still very, very complex for developers to use Kubernetes, and we need to do a lot of stuff to improve that. So, during this presentation, we are going to be talking a little bit about like why cloud-native applications are complicated, the things that we can make in order to make them portable across different environments, and how complicated it is to test all these things when you can like have a lot of teams creating applications and pushing code to different places. Then we will look into the testing side of things, right?
Exactly.
And at the end, or like towards, like during the presentation, we will be talking about Dapr and Microcks, these two projects, and how you can use them. But the idea here, the things that we want you to take away from this presentation is the patterns that we are using to test and to abstract away the complexity of cloud-native applications. You don't really need to use these projects, but you should look into the patterns, because those patterns apply across different tools. So in order to start the presentation, we thought, okay, we have a demo. We wanted to show you kind of like an application that is running here, and maybe we can just show that, right?
Yep.
You can actually run that application in your laptop if you want to. It's in a GitHub repository. The application is very, very simple. It's just simulating placing an order into a pizza store. And what you can see here is that we just place the order. So the store picks the order, then the order is forwarded to another service that is called the kitchen service that will prepare the pizza. And we will get like asynchronous notifications about the state of the kitchen. And then when the kitchen is ready, the order will be picked up by the delivery service, which is basically sending events about where the order is until it actually reaches to the house that the pizza was ordered to. So very, very simple application. This application has a very simple architecture as well. It looks like this. Right? So we have the store service, which is placing where you place the orders. Then you have the kitchen service that is preparing the, the order and then sending asynchronous events to the store so they can be forwarded to the user. And as soon as things move forward, we can go to the delivery, which is doing the same, kind of like sending messages asynchronously for the user to be updated or where the order is.
Yeah. It looks very easy like this.
Yeah, it looks like it's just 3 services, but pretty simple, right? The first thing that we wanted to do is just, because we are here in Spring I/O, like if you need to do this with Spring, how would you architect this application? It's pretty straightforward, right? Like 3 different microservices, the store service, the kitchen service, and the delivery service. And if I needed to code this really, really quickly, I will just use something like for like Postgres SQL to store the pizza order when it arrives, so I don't lose it. And then I will use something like Spring Messaging or like Spring Kafka to be more specific to send messages via Kafka whenever we have any updates on the services, right? So things are happening in this service, we need to update the store about what's happening. We will just place messages on the Kafka broker and the store service will pick it up. And we are missing kind of like the front-end side of things, but we are sending via WebSockets to the user messages and events. Super straightforward things, right? How can we make this more complicated?
Yeah, that's too easy.
That's too easy, right? But yeah, but like that's how I would do it, right? Like as a Spring user, that's what I would do. The problem begins when actually you start creating real life applications. Dependencies become a thing, right? Like you need to add things for like, probably you have some sort of authentication service that you need to connect to, so you need something in the Spring ecosystem to do that. Maybe you need to load configuration values from maybe HashiCorp Vault or any other cloud provider solution for consuming configuration values. and at some point you will need to start caching data around between services. So something like a Spring Data Redis, or just using the Redis client to send stuff to Redis might make sense. For HTTP session caching, or like even like caching the orders if you don't want to go to the database all the time. So the application gets complicated, it gets bigger, and it starts taking a lot of other responsibilities. And then cross-environment thing, right? Like you want to deploy this on AWS, so now you don't have like PostgreSQL running locally, you have it remotely. You don't have Kafka running in your cluster, but you have Amazon SNS and SQS. And from the application point of view, you actually need to start changing the dependencies. So even if you are using something to run the application locally, when you run it on AWS, you will need to have a different version of the application with the AWS SDKs and all the configuration that's needed. That's one aspect. The other aspect is connection pools. And again, like the things that are going to happen inside the application. If you are connecting to PostgreSQL, you not only need to configure Postgre, like the Postgre JDBC client here, like the driver, correctly, but also you need to configure how many connections this application is going to make to that database instance to make sure that this application can scale, right? Like it really depends then, depending on the environment where you're running this, how many instances of this application do you have, and how PostgreSQL is configured in order for this application to work correctly. The same with Kafka, the same with like resiliency, like you actually need to learn how that library works in order to be able to set it up correctly for your use cases, right?
Yeah, it doesn't look that simple now.
Now it's getting more and more complicated, right? Like, and now the application is doing a lot of stuff. Every time that you see something like connection pools, you need to think about memory and how much resources this application will consume. And then the next step, which is you want to deploy this on Kubernetes. So now you need to start creating containers, and you need to start understanding how Kubernetes works in order to be able to deploy this service into a cluster, right? And that, for developers, in my opinion, it will just slow you down unless you have the right tools to do the right things here, like just to containerize and actually deploy to a cluster. Also, extremely important, if you are deploying to a cluster, as the developer, you can run these services inside the cluster itself, but when you're running more in production, these services are going to be outside of the cluster, managed by DBAs, database administrators, and you will need to figure out how to find those like instances and where they are and how they are configured. Sometimes you will not even have visibility on how they are configured, so you need to guess or trial and error, which is worst. The good thing is that in the Java ecosystem, we have some tools to deal with this complexity, right? Like Testcontainers will allow us to create a setup, a local setup for this application to work. So I can start this service on its own, and I can start all the infrastructure that is needed by this service using Testcontainers, right? That can take a while, but as soon as you manage to create one of these configurations, you should be fine. But the problem becomes now the problem becomes when you start having more and more services, and the dependencies between the service and the infrastructure that is needed from these services, and the connection between these services start becoming fuzzy, right? Like you are maybe a developer in this service here, and you don't understand what these other services are doing. So if you want to bootstrap like a new instance of this service, you need to bring all these other dependencies around, and that gets really tricky, really fast. So there are two things that we wanted to discuss. The first thing is that how I've seen people dealing with these kind of problems, and we are developers, so we can understand what APIs are, right? Like we create an interface and we hide complexity behind the interface. Some companies will create frameworks to solve these kind of challenges. Just if they start noticing that in an architecture like that, you start having a lot of developers spending time figuring out how to connect to the database, they will create some sort of framework just to simplify that. Like just bringing all the defaults that all the teams can use at the same time. And that usually creates some issues of bringing back all the services, gluing all the services together, creating kind of like some sort of distributed monolith that is very hard to upgrade and hard to release like independently. So there are like different ways that we can use to abstract the complexity in this case, but using APIs is usually the way to go, right? And what do I mean by using APIs, right? Like you have a legacy service written in a language that you don't know, and developers from Spring Boot are having hard time to connect to. You create an API, abstract away the complexity so you can run the API to connect to the legacy service, but the teams here, they don't really need to know about this service. Now they need to only understand about the APIs. The problem with this is that then you need to run these APIs at scale. And you need to provide an implementation of this API for local development so these developers can also work. Which takes me to Kubernetes. And as you saw from the books and from my past experience and for the project that I'm working on, there are like different approaches when we think about if we are running our applications on Kubernetes, we can push some of these complexities down to the Kubernetes level instead of keeping that inside of our application. So how would it work? So in this way, like we have our applications that are doing their business logic, right? Like the same implementation of things like publishing events or receiving orders and storing things. But now we have an API that abstracts the complexity of connecting to this infrastructure, right? And those APIs provide developers all the functionality that they need without the need of understanding what that infrastructure is or where it is. So that makes your applications a little bit more portable. Now you can deploy, your applications to AWS, to Google, or to Azure, and configure this API to connect to these environments without like changing the application code. That's kind of like the approach that I'm talking about here. And again, because we are moving the complexity to the APIs, all the connection pools, all the specialized configurations that you need to connect to services in the cloud or even into local development are abstracted away from there, right? And as you can see, this diagram, it's very similar to something that is very well known in the Kubernetes space, which is the sidecar pattern, right? Like, so you have APIs that can be very close to the application and can be scaled with their applications. So they are not the single point of failure in your architecture. That's where Dapr comes in, right? Like that's kind of like pretty much what the project that I'm working on is doing, is providing you some APIs to abstract away infrastructure complexity and simplify application development. And because we are exposing APIs, we can consume these APIs from any programming language, right? And it's kind of like funny, right? Like when I say APIs, people think about REST endpoints. So we are exposing REST endpoints, but also we have gRPC endpoints for like low latency interactions and bidirectional communication with streaming. So that's the idea. So you have any language, APIs, and then all the infrastructure running on Kubernetes, running on virtual machines, running on-prem, any setups.
And the nice thing from a developer point of view is that you also have an API for accessing your data store. So you can run locally on a PostgreSQL base, or you can run on a cluster using a managed service, whatever. You still use the API that is provided by Dapr, and Dapr is doing the routing, the abstraction for you.
Exactly. And if you want to see the architecture of the same application that we just showed you using Dapr, it will look like this, right? Again, the application now will not have any dependencies to Kafka or to PostgreSQL in this case. It will just be consuming the Dapr APIs. You see here that what we are representing here is inside the Kubernetes cluster. So for this to work, you have a Kubernetes cluster, you install Dapr into that cluster, and then you configure Dapr to do the connections to Kafka and to PostgreSQL in this case. Right? That's the general idea. That's an explanation that will work for most Kubernetes users, but we are in Spring I/O, right? So for me, this is already sounding very, very complicated. So just to show quickly two things here is like the application that we show at the beginning is running on a Kubernetes cluster locally, and I just wanted to show the pods that are running there, right? Yeah. So what we are showing here is that we have the 3 services of the application. Yeah, you probably need to move that way, right?
Yeah.
I think that if you push the cursor, there you go. Yeah.
Oh.
So we have like 3 services. We have Kafka running in the cluster and PostgreSQL running in the cluster. But one important difference here is that none of these Spring Boot applications have the dependencies for Kafka or for PostgreSQL. Everything is being exposed by a second container inside the pod that is basically exposing the Dapr APIs. And this container is automatically injected when you define that your application wants to consume the Dapr APIs there.
Exactly.
So we want to show that, and then if we can show the kitchen service, for example.
Yes, the kitchen service.
Yeah. So the only thing that I wanted to show there is that what do I mean by using the Dapr APIs? So Dapr has like a Spring Boot integration that basically allows us to do something like this, like the Dapr messaging template, and with the type that we want to send, like as a payload. In this case, like as an event object. And then what we do is we do the same thing that we would do with the Kafka template, right? Like we use the messaging template, send to a topic, and then we send the event. The application, again, doesn't need to know which implementation of the broker we are using. We can swap the brokers now because the application doesn't have any dependency there.
Moving to Kafka, from Kafka to SNS, SQS, really easy.
Yep, or to Kafka, or to RabbitMQ. Right?
Yeah, or to RabbitMQ.
Exactly.
Yeah. Okay.
But, and if you're interested more in that specific integration, we did a presentation last year with Thomas here about the initial integration, but we have moved forward quite a lot with the integration. We had a lot of new stuff in there. We now have Spring gRPC support, we have OpenFaint support, we have Spring Cloud Config support as well. So the idea there is that you keep using the libraries that you know how to use in the Spring Boot ecosystem, but underlying you are consuming the infrastructure via the Dapr APIs. And we will keep adding more integrations there. So if you're interested, check the video out. And we also integrate with Testcontainers. So basically what we can show now, for example, is the same application running outside of the Kubernetes cluster, right? So we can start the store service. Whenever we start the store service with Spring Boot, it will automatically start the Dapr APIs and start infrastructure using Testcontainers configurations, right? We can start the PostgreSQL instance and a Kafka topic with Testcontainers, and auto-wire Dapr, so it exposes the Dapr APIs to the application. So maybe we do that.
Yeah, let me just, this one. So
yes.
Here, just launching Spring Boot test run.
Test run. So
that is executing the
test context.
The test container config. Yeah,
exactly. So we are starting the application with the test configuration there, and what we can see is that if we go to the browser. Yep. And ready. We placed an order, right? We are starting only the pizza store service, right? So we place an order, but if we go back and see the execution, we see that the order was placed, but there is no kitchen service, right? We just started the store service. There is no kitchen service started right now, so whenever it's trying to call the kitchen service, it's failing with an exception saying I cannot find that service, right? But at least as a developer, I can iterate on the store service and just change the business logic, add tests or whatever, right?
Right.
One important thing to mention, the last thing that I will say about Dapr is that it's not about using Spring Boot or Dapr. You can actually use them together. That's why we built that integration. And it doesn't mean that when you start using the Dapr APIs, you need to go full on the Dapr APIs. We have seen a lot of companies, for example, keep using Spring Data with Postgres straight away. But for the messaging side of things, for publishing messages, they started using the Dapr APIs to abstract away, again, the broker. I've seen a lot of migrations from Kafka to Pulsar, from Pulsar to Kafka, or from Kafka to a cloud provider, a managed service. And all of those migrations kind of make sense. When you have a generic API that abstracts that away, it's much easier. But one more thing, which is actually the topic of this presentation. The topic of this presentation is when we have a simple service, it's easy. When we start having more services and we require more configuration, this gets tricky, right? As a developer, wiring up all these things gets really, really tricky, and it can become very, resource intensive. Right? Again, if you need to start up another 10 services to just write tests about the business logic of this service, this is kind of a complicated issue, right?
Yeah, typically that's where the mess happens, because Testcontainers offers nice solution for all the dependencies related to infrastructure, but still you have this architecture when your business service depends on another business service. So it's still manageable when you have 1, 2, 3 dependencies, but then if you go above this threshold, it becomes a mess. So as soon as you had new service dependencies in your distributed architecture, distributed application, that's where the pain is growing also for developers. And so we have to face many, many different challenges. And the first one for me is the one of the cognitive load. At the beginning, it was easy. Everything was Maven. So Maven package, Maven install, Maven Spring Boot run. But then we started to have other tools. And then you have to manage maybe the front end, or wanted to try another stack. Or maybe you are now dealing with Go microservices as well, or dealing with all the stuff, just shell scripts. Some of your teammates did introduce Docker Compose. So now you have also this complexity of managing Docker Compose files. So at the end of the day, it's a real burden to remind all these commands and to know what commands to execute at what time if you want to reproduce the full setup, the full environment with dependencies on your laptop.
Yep.
The second problem also, I would say, behind the cognitive load is the one of the resources, because imagine you're working on your Spring application, and you say, hey, it has a number of dependencies, and it's a nice idea to use containers. Okay, so I use those containers, those dependencies containers, but those dependencies have dependencies that may have dependencies and other dependencies. And so at the end of the day, we met a lot of people who start to put everything into a local Kubernetes cluster. And then the cognitive load also grew. And you also have new problems to solve, problems like updating images, like updating test datasets, refreshing test datasets, refreshing volumes, this kind of stuff. So I'm not saying do not use containers, but do not use them like this, because it soon became unmanageable. And the problem is that with that, we are just using a lot of resources, consuming a lot of CPU just to running dependencies. Okay, so a lot of money, a lot of complexity, a lot of power, of energy.
Imagine the amount of time that you can spend like just troubleshooting something that you're starting to test your service. Like if you are spending time troubleshooting the things that needs to run for you to test your services, then you're wasting a lot of time. It would be great just to have like a simplified version of that you can run. You can be sure that it works and it does what it needs to do in order for you to test your behavior.
And you don't need a new laptop every year.
Yeah.
Okay, so the temptations are great to take shortcuts as a developer because we want to lower the pain. So the first thing we'd like to do is maybe avoid testing integration, just focusing on my store component and just forgetting about the rest of the world. But you know that in those days or distributed apps, this is a very risky bet, So you're looking to stuff like using mock frameworks to mock all your dependencies. And that's nice, but you don't, it's not easy to detect all the kind of issues you could have with those mock frameworks, because these are typically running into your VM, into your runtime, and so everything related to network connection, everything related to JSON or Avro serialization, if you're working with Kafka, you're just blind regarding those issues.
Yep, that's true.
Yeah, and the third shortcuts is about just relying on your own vision. I mean, you're looking this API documentation for the third-party dependencies. It looks easy. So you say, just writing my own mocks looks easy after all. It's just a few lines of code. But after some weeks, months, you realize that you misunderstood some stuff. You put your own bias into your implementation. So you really need to rely on something that is, I would say, the source of truth, so that you don't misunderstand and you don't bring your own interpretation. That's so correct. Rely on something that is external, could be a source of truth. The nice thing with distributed application is that we're living in a service-oriented world. So services means we have interfaces, we have APIs that describes features, promises to be delivered, and those features can be codified as contract. Yeah, I know what you're saying, what you're thinking. Contracts sometimes they have bad reputations because they are they make you think about governance, about constraints, about just documentation you're managing, you're generating at the end of the day. But until you find a very pragmatic way of using contracts. And that's what we are doing in Microcks. So Microcks is a CNCF project, and in a nutshell, it works like this. It reuses all the different assets, all the different contracts you may have in your repository. It is able to ingest everything, so I mean OpenAPI file, gRPC protobuffer, GraphQL schema, all this kind of stuff. It is able to ingest things to produce on-the-fly simulation for your dependencies, whether they are REST synchronous dependencies or whether they are asynchronous dependencies like a consumer or a producer that is using Kafka, for example. So very quickly, in a very lightweight manner, you just have mock API that your consumer can start using without having any implementation, okay? And the second part of Microcks is that once it has also ingest all those artifacts, is able to create a comprehensive test suite for your implementations. So this is contract testing, but very easily and without writing any code. Just reuse all your contracts, all your different assets to assume what could be a full and comprehensive test suite for your API implementation. So that's way, using both parts, both the mocks and the test, you are sure that you can work in full isolation regarding your third-party dependencies. As a store component, you don't need the kitchen or you don't need the delivery component. And what you will actually produce will be conformant to the spec, so you will lower all the drifting risk and all the integration risk that will come later on.
Yeah, for me, it kind of like became quite clear that this is a very useful tool when I said, I have this open API spec, and I can have a server that is serving me that open API spec out of the box without me doing anything. I just put the resource somewhere in the class path, and then I start like a server that it's going to serve all my contracts that are also versioned. So now I can test against different versions of the same contract to know that whenever the kitchen team upgrades their service, I will be conformant with that service and nothing will break.
Yeah, exactly. And so you may wonder how to execute and where to execute Microcks. So you can choose either the inner loop or the outer loop. Choice is yours. So you can deploy and reuse Microcks on many different stages of your life cycle. And so typically here today we will focus on the inner loop, on the developer's laptop, and how to integrate it using very lightweight containers, but you can also deploy this on a Kubernetes cluster using, for example, a full GitOps-oriented approach if you want to provide new sandboxes, realize new tests on the fly. Okay? And I think that's it.
I think that's it. Let's
switch to the demo.
Let's look at that. Yeah.
Okay. So first thing first, we are going to restart our application with all the full dependencies. So just to show you that Microcks can also bring the whole comprehensive environment just for you in a very lightweight way. So you don't have to start the kitchen service, the delivery service, whatever. It all simulates them and plug them into the Dapr sidecar containers. So now when I go back to my application, I can place order, and I no longer have the exceptions. Now I'm calling a kitchen service that is actually a simulation that has been provided on the fly by Microcks. So no more errors, no more exceptions.
So kind of like the idea is that now we are starting our service for development purposes, but now we have all the contracts in place just to build functionality and just hit these contracts whenever we need them. And we can codify which kind of like responses do we want to get for this environment specifically. Yeah. What we are showing here with Maven test run is kind of like what the developer will do when they are just making changes and trying their applications. But of course, this makes sense in the context of testing, right? So we can actually go and take a look at how the configuration for writing tests against this looks like.
Yeah, exactly. So you can see that it's super easy to just use Microcks. You can use a simple configuration in your Spring application and just say, hey, start Microcks. And by the way, we can see that Microcks is available in a GraalVM native image. Under the hood, it is a Spring application, and it is compiled and made available as a native image. And you just say, hey, connect to this Kafka here, provide simulation for all these artifacts, all the OpenAPI files, all the async API file you will need, and then it can plug itself into the Dapr configuration. Yeah. So from a Dapr configuration point of view, the nice thing is that here, for example, when you're starting your Dapr container with your test container configuration, you don't have to worry what is the actual endpoint of the simulation that is provided by Microcks. You just say, hey, Microcks, give me a mock endpoint for this API with this version. And everything is just wired into the Dapr sidecar, so the Dapr sidecar still do the discovery of the service and so on. Yeah,
the idea here is that, again, we are just replacing an instance of the service that we should be running in order to run tests to validate. And for example, in this case, the idea was that we are sending an order to the kitchen service. We want to wait for the kitchen service to prepare the order so we can actually test the delivery process, right?
Yeah.
So in this case, we just wired up the contract for that very specific version of the kitchen service.
Yeah, exactly. And we are doing exactly the same stuff for all the asynchronous services as well. Mm-hmm. The Dapr sidecar say just, hey, Microcks, give me a Kafka mock topic for this service. Mm-hmm. And Microcks will generate everything under the hood and will start acting as a fake producer that is producing messages and so on.
Yeah. So
we'll see later on how he does things.
Perfect.
Okay, so this is for the mocking parts, and it allows your developer to have a fully isolated, autonomous environment that is very lightweight, very cheap to run, because you don't have to run all the dependencies. Everything is actually simulated. But now, how to be sure that what you are developing is actually conformant to the specs and will not raise issues when you will integrate your components with the other ones on QA environments, for example. So the first thing we can do also with Microcks is doing contract testing, okay? So let's say, imagine, for example, I want to check that the API I have in front of the placeholder function is conformant, does not introduce breaking changes regarding the consumers and so on. So if I look at the code, what I want to check is that this placeholder method actually returns a correct order. So there is an easy way to do that using, for example, mock frameworks, okay? Or using REST assured. So you start your application, you use a library like REST assured, and you just enter a loop, and you are calling different, you are issuing different calls, and for each and every call you are checking, did I get the correct response code? Did I get the correct content type? Am I able to parse everything as a JSON? So it's easy, but it could be really cumbersome when you start to have dozens of different cases to check. The approach we have with Microcks is to directly leverage the contract we have, the OpenAPI file, to do everything dynamically and do not have to code the stuff, or just a minimal set of stuff to code, okay? So typically with Microcks, the approach is just include Microcks in your project and the OpenAPI file, launch Microcks test, and everything will be done automatically for you. So Microcks will act as a consumer of your API and will check for each and every request it finds that you're absolutely conformant to the schema, to the different information you find in this OpenAPI file. So, for example, here I have this OpenAPI file that describes the create order operations. And you can see that in this file, I have everything I need to check that my JSON serialization is actually correct, okay? I got types for the different properties. So everything is actually already here. I also have the information of the content types on the status code I should have. So you can just use that without writing anything. How do you do that? Just start a test request, a Microcks test request, where you say, hey, I want to test this endpoint that is actually my local Spring Boot running application. I want to check that it is conformant to this API with this version, simply put. Okay, I'm going to run this. And here, I'm just say to Microcks, test me this endpoint. And you will see that it acts as a consumer of your API. It issues all the different calls and check everything, do all the schema conformance checks for you on the fly. So what you receive is just a test result, and then you can just assert different stuff. So for example, you can check that this API has been tested with 2 different samples. How do I know that we have 2 different samples? Because in my OpenAPI file, Microcks has actually reused the different examples that were provided to rebuild a full test suite just from your example. So as soon as you have examples into your OpenAPI file, you can dynamically turn it into a full test suite with Microcks without writing code or very few code, just asking to run the test.
And just to reinforce, right, like we are running this contract testing against a service that is using that abstraction from infrastructure. That basically means that we can run this contract test against like different configurations for the infrastructure that is set up behind the APIs.
Exactly. And you can run this contract test against different versions. Mm-hmm. So it allows you to check that when you introduce the version 1.3, you did not break the semantic versioning, and the 1.2 is still okay, the 1.1 is still okay, and so on. Okay, so that's the first kind of test we can do and check with Microcks. So let's get to something much more complicated.
Mm-hmm. Yep.
So now let's switch to the kitchen service component, the one that is actually emitting event when an order is being prepared. Okay. Here, what we want to check is that the emit event method, the one we see here, Pizza Kitchen, and the one that is very basic because it delegates everything to the Dapr template. We want to check that this one behaves correctly. And so the typical approach would be to integrate a mocking library like EasyMock, like JMock, Mockito, whatever. Prepare a mock object for your Dapr template and check that the same message has been called. Okay? But actually, what you are testing is just that the emit event method actually works. That's it. What we want to do with Microcks is being able to go further and to be able to test the whole scope. I mean, as a developer, my scope of responsibility is not just the Spring Boot part, but it's the Spring Boot part plus the Dapr configuration plus the fact that the event actually arrives on the Kafka topic. I'm not just throwing away events. I want to be sure that the events are reaching the correct Kafka topic.
But also they have the right format.
But also they have the right format, yes, because if you are sending badly shaped messages, who cares? The
Who's going to consume it? Yeah.
Exactly.
They will break, right? Like same as with the REST API. Important thing to mention here, you see the Cloud Events logo there. Cloud Events is a specification that basically adds metadata to your events. It's just a wrapper for the event. And that's used a lot for dynamic routing of events, right? And in this case, the moment that you place an event through the Dapr APIs, Dapr will automatically wrap your events using Cloud Events specification. And now what we are going to test with the Async API and Microcks is that that's basically compliant.
Exactly. And you will see that for this asynchronous interaction testing, the principle is exactly the same that for the REST API test we just did before. You include Microcks, and this time not OpenAPI but Async API. You launch a Microcks test and just have to wait for the result. Okay? So here we rely on an important contract that is OpenAPI. That is Async API, sorry. Who is aware of Async API?
How many people know?
How many
API?
people?
Yeah.
Yeah, that's good. So basically, for those who don't know, Async API, it's a sister specification to OpenAPI, but just dedicated to asynchronous exchanges. Okay, so you can see it also has a title, a version. Okay, and it allows you to describe the different channels. So here, typically, the channels will be mapped onto Kafka topics. Okay. It has an abstraction layers, and it allows you to dissociate the channels from the actual technology bindings. Yep. And here
more APIs, abstracting away.
Exactly. And the nice thing here is that we also have the descriptions of the different messages payloads. So typically, we will provide orders, and we will write them into a cloud event. So here we are describing two things. We are describing the cloud event envelope, and then the data that is wrapped under this cloud event envelope. And you see that the nice thing is that you can use references to refer to standards, for example. Okay? So from a Microcks and from a test point of view, you will see that it's basically the same stuff. What you have to initialize is a test request. This time it will be an Async API schema conformance test. Okay. You want to test the conformance with this API, the name that you found in the Async API file. Okay. And you say to Microcks, hey, connect to this topic when you expect to receive messages once you invoke the emit event method. Okay, so here you need also to trigger this method. So we prepare an application event and we launch the Microcks test, and we just have to wait because we will get a result at some point. Okay, so let's launch this application, this test, and we can see further on. So here, for example, I just have to emit the event and then wait for the results. So we have timeouts, obviously, and within a few seconds, yes, so I just received the events, and here Microcks has tested that what I have sent on the Kafka topic can be actually read by the other consumers and is actually conformant to the schema. So you did not write anything, just launch the test, and everything is deduced from the async API file for you. You can go further if you want. You can, for example, no, not this one. Where is it? I don't know. It's too small. You can, for example, check that you received the correct number of messages. Okay. You can also check the content of the messages that has been received, that has been validated by Microcks, checking that you have the correct properties that has been automatically filled by the Dapr SDK. You can check also that your object can be used as a cloud event object. So you can do many more tests, but all the things related to let's say the wiring, the sending of the Kafka message over the wire is actually done automatically for you by Microcks. So automatically it starts broker, it checks that the messaging template has been called, that the message has been sent over the wire, that it arrives on the correct topic, and that it can be consumed by all your different consumers. Okay, is that clear?
It's good. Yeah.
Yeah.
Good.
Okay.
We know we are between lunch and your stuff, so let's speed up.
So actually, the scope you are now testing is the whole scope, so you can be sure that the consumers will be able to consume the events. So, a latest one, typical one from the store service perspective, you want to be sure that when you receive an event from the Kafka topic, because, for example, the preparation of your pizza is ready, you are calling the delivery service. So typically here, the typical approach is also to invoke receive events and just check that the delivery service has been called with some mocking tools, checking that just the call at the Java level has been done. But you can go further with Microcks as well. Here, the point is that you will want to check the whole scope. And in fact, you will just have to include Microcks and async API, wait for some time, and check that at the moment the delivery service has been really called. That's not more difficult than that. So let's just show you the code. So this is what we are doing here. Okay. So you have to have in mind that when I start my test, Microcks actually starts also under the hood and starts acting as a fake producer. So it produces message on a Kafka topic your application is bound to. So your test is you just have to wait. You just have to wait, let's say, for 4 seconds and just check that at some point you receive an order, okay? And you can then check that the delivery service has been invoked when this order has been received and processed by your application. So that way you are sure that you have the ability to receive order, to deserialize Kafka events, to trigger the correct business function on your application that calls the correct remote services upon the arrival of this event. You may wonder where this ID here is coming from, and that's normal. And typically, this is coming from the async API file, because here again, like for the OpenAPI file, Microcks has reused the examples you have put to describe your payload, to describe your headers and so on, to form the comprehensive data sets, and it reused this to simulate your consumers and your producers. So as soon as you have described your example in your specs, you can turn this into a full mocking environment and a full contract testing environment for all the asynchronous protocols. So here again, I can just run this test. It will take a few seconds, but in the end, you will check that the whole chain is correctly done and everything has been processed correctly. So what you are testing is actually the full scope of the application, not just a part or an interaction between two Java classes.
Great.
And I think that's it. That's a wrap.
I think that's pretty much what we have to show today. I know that it's a complicated, presentation with a lot of moving parts. But again, we have the pizza repository on GitHub, where you can actually inspect all the code and run it. We believe that we are showing patterns here that can be reused by other projects because we are combining just things together and wiring things up. And again, just trying to show two sides of the entire picture, right? We're using contract testing not only for HTTP requests but also for async interactions. By doing this, we are just removing the complexity of starting these services and other dependencies. So we're just scoping these for the store service team. And we believe that because using tools like Testcontainers, we actually can create libraries with these configurations that we can share across teams. And we have made the developer life easier by, again, reducing the scope, but at the same time testing across different infrastructure, across different environments. We know building distributed applications is hard. Making applications portable across environments is really, really hard unless you adopt an approach to abstract away complexity from the environment. Dapr is one of the solutions that can help you that, and it has the Spring Boot integration there that it's evolving. So if you want to contribute there, more than welcome.
Yeah, and that's really nice is the combination of both projects. So Dapr is there for abstracting all the things related to infrastructure, but you still have the same pain, the same issues for your, let's say, regular business dependencies. And Microcks is there. And I would say that finally it makes contracts easy and useful, not just for documentation, not just from a governance point of view, but also in day-to-day developer experience. And yeah,
thank you so much.
Thank you very much.
We have questions, which I love.
Yeah.
Let's do it. Okay, question. Yes.
Yeah, having that timeout in the test method, waiting 4 seconds can be fragile. Is there a way that Microcks can give a callback saying like, I published the message?
Yeah, it's a feature enhancement we get recently and something we will probably work on in the next versions. We have this kind of stuff already when you are using Microcks on the Kubernetes stuff, because typically all the tests can be triggered using a custom resource. And this, once the test is finished, the custom resource is updated so that if you're using stuff like Argo CD or Argo workflows, Argo events, there is an easy way to have some callbacks
yeah.
when the test is actually finished.
Makes sense. Any other questions? Yes.
Can Microcks also return mock data, you could say, for an API? So if I have a test that wants to just test or get data from an authorization service or something like that, would it be able to return data to me in my test?
Yeah, typically, yes, it is capable of mocking any services. So it could be technical services like, for example, an OpenID Connect authentication workflow. We have some adopters that are doing that because they moved to the cloud and they have to implement a zero trust strategy. But it was a real pain for developers on their laptop, and so they decided to mock all the OIDC ceremonial with Microcks.
Good. Yeah.
Yeah.
Is it generated on the fly or generated once, you generate it once and you pass it to Microcks?
Okay, so for the first question, no, at the moment it's not possible to check security assertions. Okay, so we are not doing that. And for the test data, we have an approach, or we want to rely on the source of truth. So we are just using the data we collect into the artifacts you put in Microcks. So it could be OpenAPI files, but if you have data in Postman collections, if you have a recording of live traffics, you can put everything in Microcks and it will merge everything to build a consistent set of data. And you can also, if you want, plug Microcks to LLM and will provide proposition to enrich your data set more quickly. So, yeah.
Last question, do you also support GraphQL?
Yes, sure.
Yep. And WebSockets.
And WebSockets and gRPC, yeah.
Good stuff, guys. Thank you so much.
Yeah. Thank you.